All right, so it turns out that these rational functions have both vertical asymptotes and they have horizontal asymptotes, because when we look at them, you often see some sort of behavior like this. This is just our parent function, right? So you see that we do have a vertical asymptote at 0, but it also appears in this case that we have a horizontal asymptote. So what we want to be able to do is figure out where those horizontal asymptotes are as well. And it turns out the way to do that is just by using polynomial division, which is convenient because we know how to do that. So what we're going to do is we're going to figure out where their asymptotes are of these functions using the methods we learned in the last video to find any vertical asymptotes. And then we're going to find horizontal asymptotes as well by doing some polynomial long division. Okay? And if there's a case where synthetic works, then we'll do that, but usually long division is going to be the way that this is going to go. All right? So we're determining all asymptotes. First, let's determine any vertical asymptotes. Well, we should remember from the last video that that just means take your denominator and factor it. So I have to factor that denominator, and I'm going to use double bubble, so factors of -3 that add up to -2. I'll go with -3 and 1. So x minus 3 and x plus 1. All right, so what I've figured out so far, just based on my factors of my denominator, x equals 3 and x equals -1 are my vertical asymptotes. And that's because if I were to write the domain of this function, I would say that the domain is all the real numbers when x is not equal to -1 or 3. Right? Those wouldn't be in the domain, and because they wouldn't be in the domain, I have to say that there would be a vertical asymptote there. And that comes from the last video. All right, but now what we're going to do is we're going to examine where there might be some horizontal asymptotes. And in order to do that, we're just going to do the division that we see here. So this is telling me to do x squared minus 9 divided by x squared minus 2x minus 3. All right, so I'm going to have to execute this division here. X squared goes into x squared once. That gives me x squared minus 2x minus 3. I subtract, those cancel, and I'm left with 2x minus 6. Now we're stuck with our division because x squared doesn't go into 2x. But that's okay, because what we were trying to do here is just figure out what the quotient was. Remember, when we write our quotient, we write it of the form q of x plus r of x, because that's your remainder, over b of x, which is just your divisor. So in this case, that would be b of x. So if I were to write this quotient out, I would write 1 plus 2x minus 6 over x squared minus 2x minus 3. And it turns out that that q of x tells you where your horizontal asymptotes are. So I would be able to say, based on this, therefore, y equals 1 is a horizontal asymptote. And you don't need to worry about the remainder right now for these purposes. The remainder is what's left over, and as we approach infinity, this is going to become 0, or negative infinity, this will become 0 anyway. So we're really just looking at the quotient. So when we're determining the vertical asymptotes, we do exactly what we did in the notes yesterday. But when we're determining horizontal asymptotes, we're just doing polynomial long division, which is something we should already be pretty familiar with. Let's do g of x. Vertical asymptotes are determined by factoring the denominator. Okay, so we've got to break that down. And actually, there is a typo here. That's supposed to say x squared minus 1. So go ahead and change that. All right, so vertical asymptotes, we've got to factor that denominator. And x squared minus 1, if you use difference of squares, or double bubble, factors to x plus 1 and x minus 1. So what that means is that x equals -1 and x equals 1 are vertical asymptotes. And that's because, remember, the domain of this function from yesterday would end up being all your real numbers when x is not equal to -1 or 1. We have to throw those out of the domain of the function, so there must be vertical asymptotes there. But where are the horizontal asymptotes? Well, to figure that out, we're going to have to do some long division. So I'm going to do 3x squared plus x minus 5, and I'm going to divide that by x squared plus 0x minus 1. X squared goes into 3x squared 3 times. I end up with 3x squared plus 0x minus 3. Those cancel. I get x minus 2, and x squared does not go into x, so we're done. We end up with a quotient of 3 and a remainder of x minus 2 over x squared minus 1. But remember, the only part of this that we really care about right now is that quotient. So therefore, y equals 3 is a horizontal asymptote. All right. I would recommend trying this next one on your own. You've seen 2 done, so challenge yourself here and see if you can do this last one on your own. So pause the video, try to finish it, and I'll go through the next steps here. Okay. For a vertical asymptote, this one's pretty easy. Got to figure out when the denominator is 0. If the denominator is already factored, it's just x plus 1, then that means -1 is my only vertical asymptote. So I didn't have to factor anything there. That was kind of nice. To find the horizontal asymptote, I could actually use synthetic division here because my b of x, or my denominator, is a linear function with a coefficient of 1. So I am going to use synthetic division. I'm going to put 1 for my x squared term, -1 for my x to the first term, and I'm missing a constant, so I'm going to hold that place with a 0. And then I'm going to put my -1 here because I'm dividing by x plus 1. All right, so let's finish this. So this is going to end up leaving me with 1x minus 2 plus 2 over x plus 1. So this is a little different. I'm going to write that out so you can see it a little better. I ended up with x minus 2 plus 2 over x plus 1. So in this case, our q of x is actually x minus 2. That's the quotient. And the remainder, remember, we're just kind of throwing that out right now. It doesn't really help us if we're just trying to find the asymptote here. So what I found is that it doesn't actually have a horizontal asymptote. This x minus 2 is an asymptote, though. But if you graph x minus 2, I'm just going to sketch this function now out here. If you graph x minus 2, this is a line with a y-intercept at -2, right there, and a slope of 1. So this line looks like that. And remember, we also decided that this function has a vertical asymptote at -1. So what I've just drawn here are the asymptotes of this function. And I'd encourage you to graph this function, but what you're actually going to see when you graph a function like this one, because these are the 2 asymptotes, you're going to see it do something like this. And it still is going to be totally dictated by the behavior of those asymptotes, but those asymptotes aren't necessarily both just flat, horizontal, or vertical. We have one here that's what we call a slant asymptote. So in this case, we would say, therefore, y equals x minus 2 is an asymptote. I'm not going to say it's a horizontal asymptote because clearly that is not a horizontal line. So these functions are going to have multiple asymptotes, many of them. And today You're going to practice finding all those asymptotes and just getting more acquainted with the process of doing division and interpreting what exactly you're getting out of that division.